So exercise 8.1 question 1 is in triangle ABC, right angle at B, AB is equal to 24 centimeter, BC is equal to 7 centimeter, and we have to determine sine A, cos A, and then sine C and cos C. So we can see it's a right angle triangle and two sides are given, so we can easily find the third side using the Pythagoras theorem, which is hypotenuse square is equals to side square plus side square. So using this, we are going to find the length of AC, which is the hypotenuse here, and length of AB is given 24, length of BC is given 7 centimeter. So if we say the side BC is the opposite side of the angle A and side AB is the adjacent side of the angle A, again when it comes to angle C, the opposite side will be AB, and then adjacent side will be the side BC. Okay, so for different angles the sine and cos values will be different. So here we are going to use the sine formula. When we will be calculating sine A, we will use the opposite side as BC and adjacent side, sorry, hypotenuse as AC, and then when we'll calculate the cos A, we'll use the adjacent side as AB, and then we'll divide it by hypotenuse. And when it comes to sine C, we are going to use the opposite side as AB divided by hypotenuse, which is AC. And when it comes to cos C, the adjacent side will be BC, and then we'll divide it by the hypotenuse, which is AC. So we'll solve this. The step-by-step explanation has been given on your screen. You can just go through it. Also here, the observation which you have to make is the value of sine angle. Okay, like if you see here, the value of sine A and then the value of cos C will be equal. Okay, so you'll see the cos C value is 7 by 25 and sine A value is also 7 upon 25. So you need to understand this is the trigonometric ratio angles, the relation between the trigonometric ratios you can find here. If you say the angle A, then the complementary angle of angle A will be angle C. So the sine value of the angle will always be equal to the complementary value of the cos, like the cos value of the complementary angle. So you can say sine A will always be equal to cos 90 degree minus A, which is nothing but cos C. So same, this is one formula which you will be having in the next exercise, like you will be using in the next exercise and you will be learning ahead. So this formula you cannot directly apply here because you have to prove these things. Okay, so you will take the method of taking the method of finding the sine value using the sides of the right angle triangle. So explanation has been given, you can quickly go through it. In question number 2, we have to find the tan P minus cot R. And again, the diagram has been given wherein it's mentioned the side PQ is 12 centimeter and again the hypotenuse is 13 centimeters. So here we can easily find out the third side of the right angle triangle which is missing by using the Pythagoras theorem. So we'll be using Pythagoras theorem as PR as hypotenuse square is equals to PQ, which is a side square, plus QR, which is a side square. So by substituting the values of PQ 12 centimeter and PR 13 centimeter, we'll get the value of QR is equals to 5 centimeter. So again, same thing. If you see the tan P and cot R, both are the complementary angles in the same triangle. So tan and cot complementary angles in the same triangle values will always be equal, which we will see here. Okay, so tan is nothing but the opposite side of the angle divided by adjacent side of the angle, and cot is also cot. How we'll find cot? So we'll use the formula adjacent side of the angle divided by opposite side of the angle. So by substituting the values, we'll find both the values are coming equal, and when we will subtract, like when we'll put the values into the equation, which is tan P minus cot R, we'll get the final answer as 0. So question number 3, if sine A is equals to 3 divided by 4, we'll have to calculate the cos A and tan A. So whenever you see the trigonometric ratios or trigonometric identities, then you can quickly confirm that it's a right angle triangle. Okay, so when it comes to a right angle triangle, we can use the Pythagoras theorem. And when we talk about the sine ratio, so sine ratio says that the sine ratio, how we'll calculate? We'll calculate using the formula opposite side upon hypotenuse. So we already have the value of opposite side upon hypotenuse, which is equals to 3 by 4. So opposite side value is 3 and hypotenuse is 4. So we got the two sides, like we got the two sides of the right angle triangle, which is one is hypotenuse, one is one side. Okay, so other side we can find using the Pythagoras theorem. So we are going to calculate the same here, and then we can after finding the third side, we can directly use the formulas to calculate the cos and tan values. So cos would be nothing but the angle adjacent to the like here we have to calculate cos A, so we'll use the formula the side adjacent to the angle A, and then we'll divide it by the hypotenuse. Similarly, when we'll find the tan value of A, like tan A, we have to use the formula the opposite side of the angle A divided by the adjacent side of the angle A, and we'll get the cos A value as under root 7 by 4 and tan A value as 3 divided by under root 7. So here we have to see that the tan value is coming as an under root. So we have to remove this under root by using the rationalization method. So we will multiply the numerator and denominator using the same value which is at the denominator, that is nothing but under root 7. So we'll be calculating ahead 3 divided by under root 7 into under root 7 divided by under root 7, which will cancel out the root at the denominator, and the final answer will get 3 under root 7 divided by 7. Question number 4, given 15 cot A is equals to 8 and we have to find the sin A and sec A values. So we know 15 cot A is equal to 8 means cot A is equals to 8 by 15, and we know uh, the formula of the cot, that is adjacent side upon opposite side of the given angle. So using the same formula we got the two sides. Again, when it comes to trigonometric ratio, it will always be a right angle triangle. So we can easily calculate the value of hypotenuse using the Pythagoras theorem, that is hypotenuse square is equal to side square plus side square, and then we can directly start calculating the values which we have been asked to calculate, that is sin A and sec A. So sine formula we already know, we'll be using the opposite side upon hypotenuse, and to find out the cos value we'll be using the adjacent side upon hypotenuse. Again, in question 5, same trigonometric ratio of sec A is given as 13 by 12, and we have to calculate all other trigonometric ratios. So we know it's a right angle triangle because it's we have given a trigonometric ratio of sec A. So we already have the two sides, that is hypotenuse and adjacent. So how we got it? We got it using the formula of sec theta, that is hypotenuse upon adjacent side. So we got hypotenuse as 13, adjacent side as 12. We'll be using the Pythagoras theorem to find out the other side, and we'll get the other side as 5, and then we can calculate the sine theta using the formula opposite side upon hypotenuse, then cos theta using the adjacent side upon hypotenuse, tan theta will use the sine theta upon cos theta, cot theta we can use 1 upon tan theta, and cosec theta we can use 1 upon sine theta. Or you can also use the ratios of the sides in order to calculate tan, cot and cosec. Okay. Question number 6, if angle A and angle B are acute angles such that cos A is equals to cos C, then show that angle A is equals to angle C. So triangle ABC is a right angle triangle with the vertex B, So angle ABC is 90 degrees. So we can say AC is a hypotenuse of this right angle triangle. So cos A we can find out using the formula adjacent side of the angle A divided by hypotenuse, and we'll get the cos A value as AB upon AC. Then we can also find out the cos C using the formula adjacent side of angle C divided by hypotenuse. So we'll get the cos C value as BC upon AC. So we already know that cos A is equals to cos C as given in the question. So we are just going to substitute the values. That is AB upon AC is equals to BC upon AC. So AC will get cancelled out here, and we're left with the AB is equals to BC. Now see, in right angle triangle, when the two sides are equal, the opposite angles of the sides are also equal. Not only in right angle triangle, every triangle, when two sides lengths are equal, their opposite angles will also be equal. So using the same method, we got the angle C is equals to angle A, hence proved.